Imagine fuel without fear, no climate change, no oil spills, dead coal miners, dirty air, devastated land, lost wildlife, no energy poverty, no oil-fed wars, tyrannies, terrorists, no leaking nuclear wastes or spreading nuclear weapons, nothing to run out, nothing to cut off, nothing to worry about. Just energy abundance, benign and affordable for all, forever. Thank you and good morning. At Rocky Mountain Institute, we do solutions, not problems. We're practitioners, not theorists. We do transformation, not incrementalism. So as Peter just mentioned, in less than a year, my team will finish and publish Reinventing Fire, a detailed roadmap for shifting the U.S. completely from oil and coal to efficient use and renewable energy by 2050, led by business for profit. Now, most analysts say that big energy shifts need just technology and policy, both narrowly construed. But that misses two even bigger plays: integrative design and business innovation, that is, new business models and competitive strategies. I'll sketch this morning how combining and enlarging all four of these plays can create extraordinary business opportunities as energy melds with IT and IP, making controls, communication, customer feedback, the gathering and processing of information more important than machinery. I'm going to focus on three big disruptive ideas. First, the recent shift of peak oil from supply to demand, with many tipping points already quietly passed. Integrative design techniques yielding expanding returns to energy efficiency, and how efficiency plus the micropower revolution will profitably eliminate old coal plants and has already made new central power plants obsolete. There are two big narratives here, oil and electricity, which is half about coal. Oil and power plants each release more than 2/5 of U.S. fossil carbon. Let's start with the oil story. 6 years ago, my team published a detailed, transparent, Pentagon co-sponsored study, Winning the Oil Endgame, showing how to eliminate U.S. oil use by the 2040s. Written for business and military leaders, our study was built around novel competitive strategy cases for 5 sectors. And the solution looks like this, where the upper red curve is U.S. oil use and the dashed lower red curve is oil imports. So first, we would save half the oil by efficient use at an average cost of $12 a barrel. And then we would substitute saved natural gas and advanced biofuels for the other half at an average cost of $18 a barrel. The average cost was thus only $15 a barrel, 5-fold cheaper than buying oil today, assuming that all of the hidden or external costs of buying and burning the oil are worth zero, a conservatively low estimate. Our costliest barrel of savings or substitutions would be $26 oil, and the business case is so compelling, therefore, that implementation would need no new federal taxes, subsidies, mandates, or laws. Now, 70% of U.S. oil is used in vehicles, but their efficiency can triple without compromise, but with better safety, by making them very lightweight, more slippery in moving through the air and along the road, and giving them advanced propulsion. This often improves their performance too, for example, with this Opel diesel hybrid concept car, which does 150 miles an hour and 94 miles a gallon, although not at the same instant. Triple efficiency cars can repay any extra cost in about a year, triple efficiency trucks even faster, triple efficiency planes in a few years. Now, such breakthrough vehicles can serve all purposes and tastes. For example, 10 years ago, my team and 2 European industry partners designed this uncompromised, safe, high-performance, mid-sized suburban assault vehicle. It uses 72% less fuel than its steel equivalent and would sell for $2,500 higher sticker price, a 1-year payback, because it's a hybrid electric, but its 53% lighter weight is free, as I'll explain in a moment. 3 years ago, Toyota showed a carbon fiber concept car with the same interior size as a Prius, but 1/2 its fuel use and 1/3 its weight. Its tiny battery bank is recharged by a half-liter engine tucked under the rear seat. And in April '09, RMI's fifth spinoff, which 2 days ago announced a strategic partnership with General Motors, showed this 3 to 12 times more fuel-efficient aluminum van. But unlike other plug-in hybrids, this one needs no subsidy to attract fleet buyers because its lightweight and low drag eliminate most of its costly batteries. Such platform fitness, taking the obesity out of the car, a ton of it in this case, is the key to electrification, which also creates huge opportunities in the electric sector. Now, ultralighting is the most important automotive game changer for 3 reasons. Only 0.3% of a typical car's fuel energy actually moves the driver. Over 2/3 of the energy needed to move the car is caused by its weight, and every unit of energy you save at the wheels saves 8 units of fuel at the tank. Huge leverage. But ultralight, ultra-safe cars needn't cost more to build. Here's why. That SUV you saw a minute ago has only 14 parts, each made in the body, each made with one low-pressure die set, saving about 99% of, say, a $500 million tooling cost. Each part can be lifted with one hand and no hoist. The parts then snap precisely together for bonding without needing the robotic body shop. Laying color in the mold can also eliminate the paint shop. There go the 2 hardest and costliest parts of automaking. And then the propulsion system is also 2/3 smaller, hence lighter and cheaper. All these savings pay for the carbon fiber, making the ultralighting free. New manufacturing from RMI's third spinoff, or its Japanese competitors, can make carbon fiber parts like this test piece, tougher than titanium, in just 1 minute, scaling to automotive cost and speed with aerospace performance. Also makes a good carbon cap. I'll pass this around, don't worry about dropping it. It's been whacked with a sledgehammer without even marking it. Now, if you make all U.S. light vehicles this way, that saves oil equivalent to finding a Saudi Arabia under Detroit, because ultralighting saves half the weight and half the fuel. The car gets safer because this stuff absorbs 12 times as much crash energy per pound as steel, and the car costs the same to make. My team accelerates such breakthrough oil savings by institutional acupuncture. That is, we figure out where the business logic is congested, not flowing properly, and stick little needles in it to get it flowing. Our partners range from Ford to Walmart, Boeing to the Pentagon, a bunch more. Of course, taking the world beyond oil requires 6 sectors to be transformed: cars, trucks, planes, fuels, military, and finance. And I think 3 or 4 of those at least are already around or past the tipping point where it starts getting easier, even though there's still a lot of hard work to do. For example, Boeing converted its 787 Dreamliner leapfrog efficiency into a breakthrough competitive strategy by rolling out those innovations to every airplane it makes before Airbus could steer itself out of the ditch. And 6 years ago, we suggested Detroit follow suit. 2 years later, Ford hired the head of Boeing Commercial Airplanes as its own CEO, and now Ford is a sales and innovation winner. Last year, mainstream analysts even began to see peak oil not in supply, but in demand. April '09, ExxonMobil agreed with many forecasters that U.S. gasoline use had peaked in '07 and will only go down. September '09, Dan Yergin said OECD oil use had peaked in '05 and will only go down. And October '09, Deutsche Bank forecast world oil use will peak about 2016, and by 2030 will fall to about 8% below the level today. And they assume China is going to electrify new cars only 1/3 as fast as China is actually planning to do. In other words, oil is becoming uncompetitive even at low prices before it becomes unavailable even at high prices. Intensifying this shift away from oil is a parallel revolution in how road vehicles are used. If this daily traffic congestion graph were an electricity load shape, we'd apply many new IT-enabled demand response and smart grid techniques to flatten it out. And not yet doing this for road traffic is wasting trillions of dollars net present value through idle people, idle vehicles, and idle roads. But now we can charge variabilized real-time driving costs per mile, not per gallon, make traffic free flowing, use smart IT to enhance transit and empower car and ride sharing, and compete physical mobility against virtual mobility and negatrips created by smarter land use and real estate models like new urbanist design, so people are already where they want to be and needn't go somewhere else. Those business opportunities are immense. Even more disruptive will be solutions economy business models like Zipcar that lease a mobility or access service rather than selling cars and gallons. This IT-rich transformation can boost cars' 4% asset utilization by perhaps an order of magnitude. My second big story is about saving electricity and then making it differently. These twin revolutions promise more numerous, diverse, and profound disruptions in electricity than in any other sector, a future most utilities are ill-equipped to foresee and forestall. 21st century technology and speed are colliding with 20th and 19th century institutions and culture to create an inflection point where huge sums will be made or lost. About 70% of U.S. electricity is used by buildings, 30% by industry. Roughly 3/4 of our electricity is wasted, according to my team's 1,000 technology efficiency assessment 2 decades ago, and since then, efficiency technologies have improved faster than they've been applied, so the potential savings are now even bigger and cheaper. But an even more disruptive innovation we've been hatching is integrative design, which turns diminishing returns into expanding returns to investments in energy efficiency. That is, integrative design can make very large energy savings cost less than small or no savings. For example, here's our house in Old Snowmass near Aspen, Colorado. Judy and I live there at 7,100 feet elevation, where temperatures have dropped as low as minus 47 F. Continuous midwinter cloud can last 39 days, and frost can occur any day of the year. But this house is fossil fuel free, a net energy exporter, and 99% passive solar heated with no conventional heating or cooling equipment, making it $1,100 cheaper to build. Inside is this emerging tropical jungle, now ripening our 35th banana crop. In 1984, this house was saving about 99% of its space and water heating energy and 90% of its electricity with a 10-month payback. Today's technologies, which we've just retrofitted, are even better. And the key is integrative design that gives multiple benefits from single expenditures. For example, the white arch you can see in the upper left has 12 functions, but only one cost. Hardly any component has fewer than 3 functions. Yet the house needn't look like this to work like this, and its design approach works in any climate, including eliminating air conditioning up to at least 115 Fahrenheit with lower construction costs and better comfort. The same approach works for big buildings, old and new. A retrofit now underway is expected to save 38% of the Empire State Building's energy. Remanufacturing its 6,500 windows on site into super windows that are almost perfect in letting in light without heat, plus better lights and office equipment, cuts the peak cooling load by 1/3. And then instead of replacing and expanding the old chillers, we can renovate and reduce them, saving $17-odd million at capital cost that helps pay for the other improvements and cuts the payback to 3 years. Similarly, retrofitting a 20-year-old curtain wall office tower near, say, Chicago could save 3/4 of its energy with a minus 5-month payback that is slightly cheaper than the routine 20-year renovation you have to do anyway that saves nothing. The same approach works great in industry too. For example, 3/5 of the world's electricity runs motors, half of that runs pumps and fans, and we can save about half of all the motor energy with a 1-year payback by retrofitting 35 integrated improvements. But first, we ought to stop wasting most of the energy used by the pumps, fans, and other motor-driven devices. For example, pumps, the biggest use of motors, move liquid through pipes. A Dutch colleague redesigned a typical industrial pumping loop to use at least 86% less pumping energy and cost less to build just by using fat, short, straight pipes instead of skinny, long, crooked pipes. This recent design on those lines in Singapore saved 69% of normal pumping energy at lower construction cost. So what does this mean for the electricity that's 60% used in motors? Well, from the coal burned at the power plant to the end use, many successive losses compound, so only 1/10 of the energy in the coal comes out the pipe as flow. But now turn that around backwards, so those compounding losses turn into compounding savings, and every unit of flow or friction you save in the pipes saves 10 units of coal cost pollution and global weirding back at the power plant. Also, as you go back upstream, each component gets progressively smaller and cheaper, so you save the most capital cost too. My team has lately found such snowballing energy and capital savings in more than $30 billion worth of industrial redesigns in 29 diverse sectors, from data centers and chip fabs to mines and refineries. Typically, our retrofit designs save about 30 to 60% of the energy with 2 or 3 year paybacks, while our new facility designs save 40 to 90% with lower capex. Meanwhile, that's all on the demand side. How the world produces electricity is shifting faster than most experts realize. Wind and solar power are growing explosively, while central station orders wither because they cost too much and they have too much financial risk to attract investors. By the end of this year, the industry is betting that the world will probably be able to produce 35 billion watts of photovoltaics every year. Grid-connected solar power has sustained 60% average annual growth for a decade and is entering takeoff now into low price and high volume. This renewable power revolution, the biggest infrastructure shift in history, is increasingly led by China, which is now #1 in 5 renewable technologies and just blew past its 2020 wind target. Power sources that get their economies from mass production, not from giant units, have swapped their share of global electricity production with nuclear power's share. What The Economist magazine calls micropower, that is cogeneration plus renewables minus big hydro dams, made 91% of the world's new electricity year before last. Micropower and efficiency are walloping all the central power plants in the world market, mainly due to their lower cost and lower financial risk. So micropower's output, as summarized here, is booming, while nuclear output just fell for the 3rd year. Micropower will surpass nuclear power in global capacity this year and in output in about 4 more years. Last year, all renewables made up 1/4 of global power capacity, half of the new capacity, over half of the power plant investment, and they generated 18% of global electricity. Renewables, except big hydro last year, got $131 billion of private capital and added 52 billion watts, while new nuclear plants got no private capital and lost capacity. In the US, they're over 100% subsidized, but they still can't raise any private capital because they have no business case. So here's the number of reactors in blue and their capacity in red that the International Atomic Energy Agency lists as under construction in each year since 1950. The nuclear renaissance is this little uptick recently to 27% of the 1979 construction peak. There are now 61 nuclear plants officially under construction. However, of those 61 units, 12 have been listed under construction for over 20 years. 39 have no official startup date, half are late, 72% are in 4 untransparent power systems. All 61 were bought by central planners, and none were free market transactions. So, with nuclear power so uncompetitive in any market system, how else can we displace the coal-fired half of our electricity, which I'll show as a magenta line? Well, first come options that are cheaper than running an old coal plant. Using electricity nationwide as productively as the top 10 states actually did on average use it 5 years ago, correcting for each state's economic mix and climate, would save about 65% of our coal-fired electricity. Of course, even more could be profitably saved. Last year, shifting fuel prices made it cheaper to run coal plants less and existing very efficient gas plants more, and that cost gap will widen. This will save 35% of coal-fired electricity at a profit, and 35 plus 65 is 100, so we already have the options needed to eliminate those coal-fired power plants cheaper than just running them. Next would come options cheaper than new coal power. Wind power, now awaiting interconnection, could replace about 2/5 of coal power. All the profitable wind power on available land could displace the coal power 19 times over. Cogeneration in industry and big buildings could displace about 65% of the coal power, plus more in small commercial buildings and houses, plus other renewables not yet counted. And then finally, there are some options that cost more today than a new coal plant, but won't by the time you could build one. Photovoltaics, for example, are in that category, and if you put them on 3% of US structures, that would displace all our annual coal-fired electricity using no land. So add all this up, and we have profitable non-nuclear ways to displace all the coal power in the US more than 23 times, but we only need to do it once. Now, together, these transformations in efficient use and diverse dispersed renewable supply are starting to flip the whole electricity sector on its head, because traditionally, utilities relied mainly on those giant coal and nuclear plants, augmented them with big gas plants, and bought a little efficiency and renewables. Those utilities were rewarded, as most still are, for selling you more electricity. But now, especially where regulators are starting to reward cutting customers' bills, the market is shifting massively toward efficiency, renewables, cogeneration, and ways to blend them all together reliably with little or no need for bulk electricity storage. These best buys save about 2 to 20 times more carbon per dollar, 20 to 40 times faster than new nuclear build could. So the market winners are also the most effective climate solutions, and they are the best solutions to nuclear proliferation, energy insecurity, and energy poverty. Now combine the electricity and oil revolutions plus similar opportunities with natural gas and direct coal, and you have the really big story, reinventing fire. So this whirlwind summary, said Peter, of our rich grand synthesis, complemented by several sectoral implementation initiatives, rests on very detailed practical experience and empirical evidence, and I think it reflects where the smart companies are headed. Of course, there's still much old thinking. As Oilman Morris Strong once said, not all the fossils are in the fuel. But as DuPont's former chairman, Edgar Rollert, said in another context, firms hampered by old thinking won't be a problem because they simply won't be around long term. And if you think anything I've said sounds too good to be true, just remember Marshall McLuhan's remark, only puny secrets need protection. Big discoveries are protected by public incredulity. Thank you very much.
Well, thank you, Amory. And John, perhaps you'd like to respond to?
Well, let me start by saying, Amory and I have known each other for some time, and it was probably a couple of years ago that we were seated at a luncheon table with our former chairman, just retired, myself and a couple other folks. And Amory asked me, says, John, can I borrow your fork? And I said, Amory, I know you're a creative guy. What in honest earth do you want my fork for? He said, just let me have it. He took my fork, and from under the chair, he pulled out his carbon hat, that carbon hat right there, and gave that thing a whack and bent the fork about 30 degrees. And I've kept that fork as a reminder that almost anything is possible working with Amory.
Sorry.
So I think the response is, one of the reasons we like to work with Amory and talk with Amory is because Amory is always pointing out the art of what's possible. And in this reinventing fire concept that we just heard, which I've just heard literally almost for the first time myself, a lot of the principles in Amory's talk, as Chevron, we would agree with. I think starting with the fact that, as an energy company, we're an oil and gas company that also has renewables. We need to be able to be looking out over the next 20 years and figuring out what is it that customers need in terms of efficiency and what kind of fuels are they going to need. And in that respect, our own company is moving more towards natural gas, which is half the carbon content of coal, 1/3 the content of oil. And we're doing that by trying to sequester carbon dioxide while we're doing that, so we're trying to handle the carbon issues at the same time. So portfolio move on a broad scale, and this is a global kind of a transition towards more natural gas. The efficiency gains that Amory talked about, absolutely necessary. They have a double win, they can reduce costs, and they also have zero carbon input. No impact on carbon at all. They take carbon out, in fact. So we, in response to that, as a company, look at energy efficiency as being the most readily available form of energy we can possibly get. And many times it's often the lowest cost and most easily done. And to that end, we've done it ourselves in our own company. We've reduced our energy intensity cost by our efficiency by 30% over the last 15 years, 20 years. And we created a business, which you'll hear from Jim Davis later this afternoon, around energy efficiency, which has actually saved our own company, that energy that we just talked about. But they also provide services to outside academia and governments. And that business has saved, in terms of efficiency, over $1 billion in energy costs for outside parties. So we're doing that, and we're taking the lessons we learned there and also applying it back inside of our own company. In terms of the nuclear versus oil and gas and biofuels and renewables, we're not a nuclear company, but we do have to have a point of view on where nuclear is going to go. And it's our belief that over the next 2 decades, we're going to need all forms of energy, and there's no single magic bullet to the energy equation here. And nuclear, in our view, has got some advantages and some disadvantages. And I think the disadvantages Amory could very eloquently articulate. The advantage is it's got no carbon content from a standpoint of clean electricity, and yet it has some other attributes that make it, somewhat less desirable. So I'm not sure where that's going to go. I think certainly we agree that the nuclear build out of the fleet has been pretty slow. And it's a lot of NIMBY, not in my backyard, permitting issues. Even with the one permit process we have now in the States, nothing much has really happened there. So that may take a long time to happen. There's a lot of countermeasures there to do that. On the biofuels piece, we're in that space too. We thought that biofuels would be actually something we could do at scale, and we try to do things at scale. So we are in the renewable business to do things at scale to make a difference for our company, and the industry needs to do that too. So what do we do in the area of biofuels? We partner up with a company called Weyerhaeuser, which is a forestry products company, and we've got 1 million acres of land. We're trying to figure out how do you convert that into biofuels. And to address Amory's point specifically, when we first went into that, we thought we could take that 1 million acres and convert that into about maybe 250,000 barrels a day equivalent of biofuels. And as we've looked at the cultivation and the mass that comes off the land and the transportation losses you get by accumulating it. We're probably thinking around 50,000 barrels a day, if that works, if technology works. And we think we can get the technology to work. That's 50,000 barrels a day out of US 22 million barrel a day consumption on oil. That's 1 million acres with one of the largest landowners in the United States. So then we start looking a little bit at the math, and this is where I think maybe Amory and I have had a good discussion. Biofuels from biomass. Our company says, let's stay away from food. We don't want to have food versus fuel issues. So we don't like corn. We don't like anything that goes on people's dinner plates. We're figuring out how to use waste. And the competition for biomass, not only for biomass to biofuels liquids, but potentially biomass to help reduce impact in coal-fired plants, which is using some form of biomass to help reduce their emissions over time. The competition for biomass is going to potentially drive up the cost of biomass, and eventually we reach a limit, certainly in the United States, as to how much we can create there. I don't know exactly where that's going to go, but we're working in that space as well. I think finally, things that we are aligned on. I think bulk of what Amory said, we think, in fact, we're acting in the way that I think Amory is suggesting we all need to look at the future. The real difference is probably in the time frame and the scale with which we can do this. How fast can we do this? And we don't manufacture cars, but we do know that vehicles now have an increasingly longer lifespan, maybe 17, 18 years. The fleet maybe turns over 7-8% per year. So if we started, today with everything brand new, that would work. We think that would, we probably have good alignment. But people, because of the economy, are holding things on. They're holding onto their vehicles longer still, and they're actually better built. So to turn over the fleet takes a little bit of time. And even with the Prius, which we see that as being a high sales unit, 2-3% sales, is still a very small percentage of the overall vehicle fleet. So I think in principle we agree pretty much. It's just a matter of the time frame, and in the end, for some of the alternatives, do we have a really clear view of the unintended consequences of the integration and the intersection of agriculture and energy supply chains? The intersection of water, agriculture, and energy. Many of the renewable energies we're now working with, we know take a lot of water. And that becomes a critical factor. So it's not necessarily a disagreement with what Amory's saying, as much as it is support for the direction and differences in the pace and the scale and the time frame we can execute in.
Okay, so now, we're not going to have these guys argue. I want to go straight to questions. So, right here.
Hi, I'm Brian Wong. I have the Next Big Future website. A question I have, well, a suggestion would be to convert cars faster because the time to take and make new cars takes longer. Could there be a way to mass retrofit the existing fleet, certainly with trucks first and then with the regular cars, where you can make them more aerodynamic and thus use less fuel at highway speeds? And then a question about micropower. Isn't that just natural gas and diesel, because it's not wind and solar, which was separate on the chart? And the external E study of deaths per terawatt puts natural gas still at 4 deaths per terawatt versus 0.04 or in that range for nuclear and 0.15 and stuff for wind and solar. So micropower seems to be more dangerous than nuclear because it's natural gas and not really away from fossil fuels. So the two aspects of it.
Yeah, maybe on the micropower, on the car issue, maybe you could address the micropower. But on the car issue, last night we had a discussion. I don't know if he's still here. I think it was Jay from Rapid Car is doing retrofits, and maybe he'd be best to answer that question offline. But certainly it's going to take a combination of factors. You know, new vehicle design, lighter weight materials, like Amory's talking about, retrofitting, and in this particular case, I think it's a good model because it's a fleet model. And it's also integrated with the grid and V2G and those kind of things, which actually have multiple benefits in addition to the vehicle efficiency. So that'd be my response on the car issue. Certainly going forward, you know, how many in the room have actually ordered their new Volt? We got one. That's one. And again, back to the question of, you know, will people pay $41,000 for a vehicle that's, you know, more efficient over time? I don't know the answer to that question, but GM has certainly tried to make that a vehicle, a very attractive vehicle. They've gotten rid of the range anxiety by putting a small gasoline engine in it, so it goes, you know, it doesn't have to worry about recharging. And, you know, there's still an adoption. We're techonomists, right? So we kind of feel comfortable with these vehicles. My daughter is not a techonomist. She called me at 1 o'clock in the morning on a turnpike between Boston and New York, and she was driving her Prius, and she's a vegan, for those of you who were here yesterday. As well, and she called me at 1 o'clock in the morning. She said, "Dad, you know, I'm broken down the side of the turnpike here, and it's dark, and I'm kind of frightened." And I said, "Well, what's wrong?" I said, "Do you have gas in the car?" And she said, "No, but I thought when the thing ran out of gas, the thing would keep going because it's electricity." So, from that standpoint, there are early adopters who can appreciate it, and those who don't quite get it just yet. Amory?
It's well known in the car business, people will run out of gas no matter how big the tank is. I didn't understand your micropower question, but I thought you were referring to carbon emissions, and we should talk offline about the numbers, which I don't think are correct according to the peer-reviewed literature. But I will just say you need to look not only at carbon emissions per kilowatt hour, but also at opportunity cost. That was the point of my last remark about how the combination of efficiency, renewables, cogeneration saves 20 to 40 times more carbon per dollar and 2 to 20 times more carbon per dollar and 20 to 40 times more carbon per year than new nuclear build. And you need to look at those opportunity costs because you can't spend the same dollar on two different things at the same time. And the nuclear industry is desperately keen that you not think about that issue.
No, I was thinking that the micropower is still fossil fuel.
The cogeneration part is mainly fossil fueled, very largely natural gas. However, that's releasing less than half the carbon that it would otherwise, burning the same natural gas to make electricity and heat separately. So it's still a considerable carbon saving. And of course, a large and increasing fraction of micropower is renewable.
Okay, we have a question right here.
So I'm Jim Smith with Digital Realty Trust, and we develop data centers, lots of very large data centers. And so, Amory, I need help.
I'll be happy to show you offline how to get 100-fold energy leverage on your data centers.
your leverage point at the source is really important, and I'm the point of that spear, right? The IT load in my sites gets levered all the way up to the efficiency chain. And I have some wonderful, wonderful designs in Santa Clara that use outside air. They approach 90% efficiency. They're great, great products. They save my customers tons of money. The further I get from Santa Clara, the lower the adoption rate goes. You know, even in Santa Clara, if I were to put one in front of the Chevron IT team, there's no way they could go with a product like this because it's too different.
Well, we
So-
just did one in the north of England with EDS,
in
now
England's the
HP.
best. London is my favorite
North
place
of
to
England.
propose these. Yet the customer base there, because they're so conservative and very traditional around
Yes,
the IT
I'm going
space.
to reinforce your point. Namely, they ended up saving 3/4 of the energy and having 4 times the capability they wanted at the same CapEx. However, had the client allowed them to carry out all our recommendations, they figure they would have saved 95% of the energy and half the CapEx and not put in all those chillers that'll never run.
So this is the challenge I have as, you know, a techonomist and an actual industrialist building these things is I have all these ideas that I want to put out there, but the customers are resistant.
Competition's
So
a
how do
really,
I get
competition's a
over
really
that?
good way to get their attention.
But even when I have the economic case that's overwhelming, you hit these institutional barriers related to perceived risk or just the difference, right? They want it to look a certain way, and this one looks different, so, you know, there's this resistance.
Well,
How do
that's
we
okay.
get through that? Is that
I just
policy
work with
question?
the early adopters to create teachable cases and competitive pressure for emulation, and the other guys figure it out.
Can I maybe just add one point to Amory's response? In a large institution like Chevron, you know, we have a VC firm, our own VC firm that actually brings in new ideas, potentially transformative ideas, including IT ideas. So, you know, we'd be welcome to talk about that.
Yep.
But part of the challenge, to be frank, on institutions is really knowing what your energy costs and efficiencies are in the IT space in a global company. You know, when we first set up the accounting system, we really never thought, I guess, many years ago, to figure out how many BTUs does an IT system use, taking into account the building and the coolers and the power to run it. And that's part of the challenge in being able to make the business case, is having the companies be able to find a way to account for that and know what their energy costs really are.
Fortunately for the macroeconomy, it appears that IT is a major energy net saver.
It is. That is
So,
I think there's a question straight back here. It's hard to see in the light, but yeah, go ahead. Okay.
Thank you, Peter. My name is Bryce Simmons, and I'm from Ghana. My question is actually for a bit of a clarification from Dr. Lovins about the reduction in fuel use due to the use of new materials. And I was wondering, particularly in connection with safety, and I was wondering whether my understanding was right, that a good deal of the weight is also contributed by non-metal parts, which also contribute to shielding and padding, like leather, upholstery, and the rest of it. And how, in that context, you know, the use of carbon fiber, for instance, will be sufficient for a significant reduction of the weight.
well, the energy absorption per kilogram is about 12 times as good for the sort of material I passed around as it is for steel. But even today, in today's fleet, which is largely homogeneous and almost all steel, at any given weight, there's a factor of 3 scatter in safety because of differences in design. And when the data that most people had concluded related weight to safety were reanalyzed, separating the previously conflated effects of size and weight, it turned out that weight kills people, size saves people because it gives you more protective crush space. Therefore, you want to decouple size from weight using metal or composite materials and design solutions. The result is you get cars that are big, if you like, which is protective and comfortable, without also making them heavy, which is hostile and inefficient. Therefore, you end up saving lives and oil and money all at the same time.
So Americans can keep their big cars.
Sure, but make them very light. Remember the car that's the interior volume of a Prius and 1/3 the weight, the one I showed from Toyota, that's an indication of where this is headed. By the way, if it were not a plug-in hybrid but a regular hybrid, that's 400 kilos curb weight, which coincidentally is what I said in 1991 a good 4-seat carbon car should weigh, to much hilarity from the industry, as you can imagine, so it's a thrill to see it happening.
And you don't have to be Arnold Schwarzenegger to lift the car anymore.
Nope.
Right. To tip over the taxi cab.
Haul it out of the ditch yourself.
Okay, I'm afraid we're out of time, and there are so many topics that I know needed to come up that haven't come up, but I hope that you'll continue the conversation now offline. And thank you both for
Thanks, Peter.
a wonderful presentation.
Thanks, John.
Thank you.